Okay, so we get to start coding or encoding, depending on where you look at it, messages using our matrices. Now, keep in mind, in real practice, these are way more involved than what we are going to do and incredibly more complicated. So if you're like, are they really coding our data using something this small and breakable? No, but it gives you an insight. Okay. So, process to encode. You're given an invertible coding matrix, so normally called A, and that's given. You need to assign numbers to the alphabet, where A is 1, B is 2, C is 3, etc., until you get through 26, and then your space is going to be 0. You are going to convert your message from letters to numbers using the coding scheme from that should be step 2. You are going to create a square matrix that is the same size as the coding matrix A. Okay. You can start with the top left corner and list the numbers vertically. If there are not enough entries to create a square matrix, you're going to fill the remaining entries with 0, those spaces. You're going to multiply the coding matrix and the message matrix in that order. And the result is the coded message matrix. Okay, you need to write your coded message outside of a matrix. You're not going to leave your answers in a matrix. And then you are going to vertically list, or sorry, no, horizontally list. We already vertically listed. Now we have to undo it. Horizontally list the numbers beginning with the first column. Okay, so the first thing that I would like you to do is get like a note card or a post-it or something along those lines, because we need to actually write out the alphabet and the numbers we're going to have for it. So A, B, C, D, E, F, G, H, I, J. Oh, probably gonna need some more room there. There we go. K, L, M, N, O, P, Q, R. Then more room. All right. Now that we have the alphabet listed, we're going to go through and number them. So A is 1, B is 2, C is 3, so forth and so on. Keep going. You're going to want to double check that you're not missing any letters or skipping any numbers. I've had a couple of students do that. Whoops. On their exams, totally throws everything off if you have S written down as 20 instead of 19. Okay, you should get Z is 26, and don't forget that space is going to be 0. Okay, all right. I know I gave you all the steps up above, and it probably sounded like Charlie Brown's teacher going, want, 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 want. So let's try to make some sense of this. Step one, they gave us the coding matrix. So they told us what A was. Step two, we need to assign numbers to the alphabet. We just did that. Step three, we need to convert our message, which was body, into numbers. Okay. So B is 2. O is 15. D is 4. And then Y is 25. Okay. After we have our message converted to numbers, we need to write the message matrix. The message matrix needs to be the same size as our coding matrix, and our coding matrix is a 2 by 2. So our message matrix is going to be a 2 by 2. Start in the top left corner, the main diagonal, and we list vertically. So our first column will be 215, followed by 425. After we have both our coding matrix and our message matrix, we need to multiply them together. We're going to take our coding matrix, which was A, the -3, -3, 2, -1, which we said was a 2 by 2. And we are going to multiply it by our message matrix, which was 2, 4, 15, 25, which was also a 2 by 2. Okay. So if we are multiplying a 2 by 2 by a 2 by 2, we're going to wind up with a 2 by 2. So go ahead and set up a matrix that has 2 rows, 2 columns. I'm going to go ahead and label these so it helps with the multiplication. The top, remember, is row 1. Bottom is row 2. And then we'll have column 1 and column 2. And remember that this is designed to help you with the multiplication. We are going to do row 1 of our green matrix times column 1 of the purple matrix to go in row 1, column 1. So we're going to have -3 times 2 plus, because it's always plus, -3 times 15. Now that we've taken row 1 times column 1, we're going to take row 1 times column 2. So -3 times 4 plus, because it's always plus, -3 times 25. Now that we've multiplied the entire first row through the entire second matrix, we can move on to row 2. We're going to do the same multiplications. We're going to have 2 times 2 plus -1 times 15. We're going to have 2 times 4 plus -1 times 25. Okay, remember when we're doing this multiplication, you take the first 2, multiply together, add the second 2, multiply together. And do the double check. Everything in our columns, parenthesis wise. So in the purple should line up. If they don't line up, they're not one on top of each other. We made an error somewhere, so we need to go back and redo our calculations. Do each of these multiplications and additions and the arithmetic in your calculator, and you wind up with top row of negative 51, negative 87. And then bottom row is negative 11, negative 17. What you just found was the coded message matrix. Okay, keyword matrix. We need the coded message, which means that we can't write it in a matrix. We just want it sent out to our peers. So our coded message, we start with the top left corner, which was negative 51, and we list them horizontally. So after negative 51, we get negative 11, negative 87, and negative 17. And that would be the list that we would enter in our online homework and that we would send to our companion for our coded message.